Okay, so now that we've spent a little bit of time with chemical formulas with their polyatomic ions that are potentially contained within a chemical formula, and we use that information to be able to count the number of atoms in our chemical formula. I promise it wasn't all for nothing. It has to do with the formula mass here. So yeah, we can figure out how many of each kind of element are in our chemical formula, but we can also find some more information about our molecule using the chemical formula as well. So the formula mass is one way we can do that. So we might call it the formula mass or the molecular mass. Either is perfectly fine and acceptable. I'm going to do my best to use formula mass as that's what your book chooses to use. However, molecular mass is the term that I learned when I was learning chemistry. Again, same thing whether you're talking about the formula or we're using that more generic term kind of like molecular here. We can find the molecular mass of things that aren't technically like molecular compounds. That's why it's better to use the term formula mass. So what am I talking about? Formula mass, molecular mass, what is it? There's more information, again, contained in a chemical formula than just strictly the number of atoms and therefore their ratios, okay? And we can also determine the mass that this formula would have. If we had one of those molecules or one of those compounds, we could determine what the mass of that compound is, okay? So that's what the formula mass is. We're able to use the atomic mass from the periodic table of the elements that make up our formula to be able to calculate the total mass of the molecule is kind of the idea of what a formula mass is here. It's that average mass of all the molecules that are in a compound. Remember that average mass comes from the fact that we have different isotopes, so the mass we see on our periodic table is an average mass. So we're going to use that information from the periodic table to figure out how much mass is in like one molecule of a certain kind. So the way that we do this, I have the formula written down here for you as well. So the formula is written down here. Basically, you take the number of atoms of that element you have, and then you multiply it by the atomic mass. And then you add all of them up for all the different elements you have. So all you're doing is basically saying, okay, I have 4 hydrogens. Give me the mass of 4 hydrogens. I have so many oxygens. Give me the mass of that many oxygens, and you add it up, okay? So that would be the way the formula mass works. For however many atoms you have, for however many different types of atoms you have, this is how your formula mass is going to work. So, what are the steps to calculating it in just a more straightforward, plain manner? The first thing that you do is you determine how many of each type of atom you have. So, you're just going to look for the chemical symbol and the subscript on that chemical symbol, okay? From there, for each individual element you have, you're going to take that number of atoms you have and you're going to multiply by the atomic mass that you see on the periodic table. And then you add all of those up once you have done it for each of the individual elements. So in the end, formula mass is basically the sum of the mass of each atom in the compound. So I'm going to find the mass of each atom and sum them up to get my formula mass. So I have 2 examples here to work through. Let me get a whiteboard. Okay, so in this video, we're going to discuss how to find the formula mass of potassium iodide, our Ki molecule here, okay? So remember, the idea for a formula mass is thusly. A formula mass, we'll abbreviate it Fn for right now, is going to be the number of the first atom. And we're going to multiply that times the atomic mass of the first atom. And then to that, we're going to add the number of the second atom we have times the atomic mass of that atom. Okay? So that's the idea here. This is our formula formula that we'll use to calculate formula mass. So let me see what I can fill in, what I know, and what I don't know. So by formula mass, the first thing that I need is the number of copies of the first atom I have. So if I have potassium here in my chemical formula as my first atom, if I check that out, that doesn't have a subscript. There's nothing written there afterwards, so we can assume that it's 1. So we have just one potassium atom, okay? So one potassium atom. So my first value here is going to be 1, and I've got that from the subscript on the chemical formula. That 1 comes from being the subscript on the chemical formula, okay? And then we multiply that by the atomic mass of the first atom. Well, the atomic mass, we can find that on the periodic table. So I'm going to check the periodic table in the front of your book for the atomic mass of potassium. The atomic mass of potassium is 39.10 AMU. Remember, that's our unit of atomic mass units. So to that, we add the number of the second atom we have. So our second atom in this case is iodine. So we have Ki. I'm looking for how many iodine atoms do I have? Well, that information, again, comes from the subscript. So I'm going to go to the subscript on iodine, which in this case, there is no subscript, again, on iodine. So we assume that that subscript is 1. So we have 1 iodine atom. So 1 there. So I'm going to take 1 atom, and then I'm going to multiply that by the atomic mass of iodine. So again, I'm going to go to the front cover of your textbook for the periodic table there, and it says that my atomic mass of iodine is 126.90 AMU. Let me double check that number. So that's 126.90 AMU. So from here, we have some pretty simple math to do. We have the formula mass equals 1 times 39.10 AMU. However, the 1 does not affect our significant figures because it's a counting number. We counted, we said we have 1 potassium atom. That is counting. That is an exact number that does not affect your significant figures. So I can say that this is 39.10 AMU plus, again, 1, not going to affect our significant figures because it's just the number 1. We counted them. We said we have exactly 1 iodine atom, okay? Not going to affect our significant figures. So that means we have 126.90 AMU as our second value here. So when we calculate the formula mass, we just go ahead and add our numbers up. So we have 39.10 AMU plus 126 AMU. Let's do this off the top of our head. That's 166. How tricky. 166.00 AMU when I add those up. So the formula mass for a potassium iodide molecule is going to be 166.00 AMU. Okay, so I'm going to do one more quick example of how to calculate formula mass. So I just want to make one thing clear. So I'm giving you 2 examples that only have 2 different kinds of atoms in them. If you need to calculate the formula mass with lots of different kinds of atoms, you do it for every kind of atom you have. So if I have one of those polyatomic ions like sulfate, so let's say I have magnesium sulfate instead. Sorry, wrong chemical formula. MgSO4. Magnesium sulfate. Well, I've got 3 different kinds of atoms, so I would need first atom, second atom, and third atom, okay? So this formula mass equation can expand to the number of atoms you need. However, I'm just doing a couple of examples here with 2 because I have full faith that A, you know how to count the number of atoms in a chemical formula as we practiced before, and B, that you understand that we would just do this for every single number. So it's just much easier for us to talk about the intricacies of doing 2 and then just do the same thing for all the different numbers you have. So let's go ahead and we will calculate the formula mass of MgCl2. Okay, so I left the equation I wrote last time up here on the board for us. So remember, our formula mass is going to consist of us taking that first number of atoms we have. So how many atoms do we have of the first kind? We're going to multiply that by that atomic mass. Then we're going to figure out how many atoms of the second kind we have, and we're going to multiply that by the atomic mass as well, okay? So let's get cracking. So formula mass is going to be the number of the first atom. So if I'm looking at my chemical formula here, that's what's going to give me the information. How many magnesium atoms do I have? Well, I check out the subscript on magnesium. I don't happen to see a subscript there, do you? Must be a subscript of 1. So therefore, I must have 1 magnesium atom. Okay, 1 magnesium atom. And then I'm going to go ahead and check that front cover on your textbook again for the periodic table. That mass of magnesium is 24.31 AMU. Okay, now I'm going to go ahead and do my second atom. So I look at my chlorine atom here. I check that out. I see, I want to know how many chlorine atoms I have. Well, I look to the subscript. I see a subscript. So therefore, I have 2 chlorine atoms. So chlorine with a subscript of 2 chlorine atoms. I'm going to put 2 right here into my formula. I have 2 chlorine atoms, so I have 2 amounts of that mass in my chemical formula. So my formula mass includes 2 chlorine atoms. So 2 chlorine atoms, and then I'm going to again go to the periodic table in the front of your book for that mass, which is going to be 35.45 AMU. 35.45 AMU. Okay? So again, I got the 1 from the chemical formula, I got the 24.31 from the periodic table, I got this 2 from the chemical formula, and I got the 35.45 from the periodic table as well. Okay? So that's where the numbers came from. Let's go ahead and do some math with them, okay? So here, again, my counting numbers are not going to interfere with my significant figures because if I have exactly 1, I have an exact number, it does not interfere with my significant figures. So, therefore, I'm going to have 24.31 AMU. And then I'm going to go ahead and multiply by 2 here. So I'll keep my same number of sig figs because, again, the 2 does not interfere with my sig figs because it's an exact number. I counted them. There are 1, there are 2. I know that exactly. Chlorine atoms in our chemical formula, so that 2 is a counting number, doesn't interfere with sig figs. So therefore, I have 70.90 AMU. 70.90 AMU. Okay? So, again, I didn't let that 2 interfere with my sig figs. I see 4 sig figs. My answer still takes those 4 sig figs. So I'm going to go ahead and add these together. Again, minding my significant figures. So when I add 2 numbers together, remember we just count the number of decimal places. So each of these have 2 decimal places. So I'm just going to be sure to round my answer to 2 decimal places. So therefore, my formula mass of magnesium chloride is going to be 24.31 AMU plus 70.90 AMU, which gives us 95.21 AMU. And I know that I have the correct number of significant figures because I have 2 decimal places, okay? So when we're calculating our formula mass, we're just using the number of atoms we have times the atomic mass of that element, and we add them up for all the kinds of elements we have in our formula. So there's the formula mass of magnesium chloride. Okay, so you saw me personally work out some of these formula mass problems for you. So that's what it's going to look like when you work through a formula mass problem. I've included some practice problems here as well as their solutions in the PowerPoint if you want to check those out. So go ahead and work through those yourself, and you should ask me any questions you have. These are going to be great examples of the kinds of formula mass problems I'm going to give. So one last thing, again, I want to remember to mention is that if you have your formula mass and you have 3 or 4 or 5 different kinds of atoms, then you just keep doing the same thing for 3 or 4 different kinds of things. So that's how we work with formula mass. Again, it's just the mass that one of those molecules would have, and we do that by adding all of the individual masses of the atoms up. Formula mass.